So in a traditional Angular application that's backed by a Cold Fusion server, when I deal with date timestamps, usually what I do is return the date time as a UTC millisecond value in my Cold Fusion API. And then on the Angular side, I would new up a date with that UTC millisecond value and then render the date in a localized time string date format. However, in a Hotwire application, there isn't an API, so to speak. There's more a collection of partials that then update the rendering of the DOM. So what I wanted to look at was how to take that kind of an idea where I have a UTC millisecond timestamp and I render it as a local time value in the user's current time zone. So let's just take a look at the demo first, then we'll come back to the code. So let's just refresh. And you can see here the page was loaded at, this is 12:43 on the server, but we can see that in the local time, my Eastern Coast time zone, it's actually 7:43 a.m. And if we look at the DOM here, you can see that here's my UTC millisecond timestamp. And if I just grab that and we jump over here into the console and we go new date, that's what I'm getting behind the scenes in my stimulus controller that we'll look at in a minute. And then what I'm doing is I'm calling to local time string. And that's where I'm getting that 7:43:15 value. Now, let's take a look at how that works. So stimulus works through a variety of conventions on data attributes. So here we have our data controller, and that's a look in the stimulus registry for a controller with the identifier of local time. Now, once we have a local time identifier, if we highlight all of these, you can see that we have a bunch of other attributes that are also prefixed with that data local time. And that's how we associate various values, classes, and targets with our controller. In this case, here is my tick count value. And then I'm also providing two different classes, daytime and nighttime classes. And you can see that that is the daytime class and the nighttime class. And what that's going to do is alter the rendering of the element based on the time of day. And we can see that here with I have some manual updates. So we can set it to night and you can see it changes to a darker, more soothing color. And then we can switch back to a day. And we'll come back to how that works in a minute. Okay, so let's take a look at our JavaScript now. And remember that we have our local time identifier here. If we jump over into our main.js, we're importing our application and controller from stimulus. We can skip over the turbo stuff, that's not really relevant. And here we have our local time controller, which extends the base stimulus controller. Now we'll skip over all this and we'll run to the very bottom here for a second. And we can see that when we start up our stimulus application, we're manually registering that local time identifier, which again is what we have here in our data controller attribute. And we're associating that with our local time controller class. Apparently in the Rails ecosystem, a bunch of this stuff is done automatically or automagically based on file names, but since I'm not using the Rails build pipeline, I have to do this manually. Okay, so let's take a look at our controller. Our controller has a bunch of static properties at the top, and this helps stimulus figure out which of these attributes map onto properties within our stimulus controller. And again, it follows the convention of data, identifier, name, and then type. So this is the value, class, target, etc. When we define things like the daytime class, the nighttime class, the label target, the tick count value, it generates, or I should say stimulus automatically generates a bunch of getters, setters, and change accessors on the class itself, on the controller class itself, that is. So for example, this daytime class has things like has daytime class as an existence check, or the value here for tick count has tick count and tick count changed, I think, and it also has getters and setters, which we're going to use. So when the stimulus framework connects our host element to the instance of this class, it calls connect here, at which point I'm going to call render time to take that UTC millisecond value and translate it into a timestamp, which we shove into our target here. So let's take a look at render time down here at the bottom. And you can see I'm doing exactly what I talked about earlier. I take that UTC millisecond value, I new up a date, so that creates a date in the user's local time zone. Then I call that toLocale time string. That's going to give me my localized time string. And then I just shove that into the text content of my label target. And then here we're using the arbitrary boundaries of 7 a.m. and 7 p.m. to differentiate night from day. And if it's nighttime, I add the nighttime class, remove the daytime class, and vice versa if it's daytime. And you can start to see some of the naming conventions here. So we have our, going back here, we have our data, local time as the controller identifier, target, label, and then that becomes in label target. That's automatically generated for us by the stimulus runtime. So we don't have to worry about searching the DOM for elements. Stimulus does all of that for us. Similarly, when we have our local time, which is again the controller identifier, daytime, the name of our class, and class, stimulus comes in and automatically creates the daytime camel case class identifier for us, which we can then use to dynamically change the host element as we want to. Now, we looked at the fact that in addition to the initial rendering here of the time, I can also come in here and manually set these values. Now, this is a really interesting feature because if we look at the main page and how that's working, this is just using a JavaScript protocol to reach into the DOM and call set attribute on that tick count data attribute. So I'm not even going through my stimulus controller class. I'm reaching directly into the DOM and I'm changing the value on that attribute. And in response to that, stimulus is noting the change in the DOM and updating the stimulus controller class to reflect the source of truth of the DOM. And we're able to tap into that with our change method. So in addition to this dot tick count value being created, we also get a change method. And if we look down here, I can override it and I can say tick count, that's the name of our value, and then value changed is the convention that we use. And if this method is available, then anytime that value changes, stimulus will invoke this method with both the new value and the old value. And if you come from an Angular background, this looks very familiar, where when the value is first initialized, the old value is 0. And so during initialization, we don't want to do anything because we're already calling render time in our connect. So really what we want is any post connect value changes. Skip over this, and then anytime that value changes, we call render time again, which does this and allows us to change the text content in the classes. So it's very cool. And here's what's really interesting, I think. So this is a Hotwire demo here, and I'm looking at stimulus, but this is also has a turbo drive loaded as well. So what that means is that, let's just refresh this. If I go to log out and then log in, and we look at the network activity, what we can see is that log out and log in are actually being initiated by fetch. These are not full page refreshes. This is Turbo going out to the server, grabbing updated HTML, and then hot swapping it into the currently rendered page. And what's really interesting about this is that all of the controllers, the JavaScript controllers in our stimulus runtime, those are automatically getting torn down and reestablished. If we look at the console here, and again, let's just refresh. So we can see we have our controller is connected. Now, if we go to the logout, what you'll see is that that controller is disconnected. And then if we go to log back in, let me collapse these, we'll see two interesting things. One, we can see all of the controller stuff is connected again, even though, again, we didn't have a full page even though we didn't have a full page refresh, but then it's disconnected. And that's because it does an initial render from the cache, then it goes to the server to fetch the updated code. And then when that updated code comes back, it strips out the existing DOM, disconnects the controller, then reconnects the controller using the most up-to-date HTML. And in fact, if we say set this to night, and we go to log out. When I go to log in, if you watch the DOM here, it'll actually briefly flash that nighttime view before it switches back to the daytime. I don't know if you could see that, but it was dark blue for a moment before it became yellow again. That's because it was pulling it out of the cache. Now, I don't know, this is just really cool because if I wasn't using Stimulus, but I was trying to implement something like Turbo Drive, I know it would be really challenging to make sure I'm instantiating the right Stimulus classes at the right time and then binding those and then worrying about all that. But because Stimulus and Hotwire, Stimulus and Turbo dovetail so nicely together, all of that dynamic creation and teardown of JavaScript classes just happens automatically for us, which means that if we ever update the view using something like Turbo Streams, we can rely on the fact that Stimulus will automatically tear down and replace instances of JavaScript classes. So I don't know, that's really cool. I'm obviously just starting to scratch the surface here, but I'm hopefully demonstrating how clever some of this Hotwire stuff is, and looking forward to playing with it more.